Today we're going to be talking about multi-step equations. Let's get started. Okay, so let's talk about solving multi-step equations by combining like terms. So we've seen that when we solve for an unknown variable, it can be a simple matter of moving terms around in one or two steps. And we can now look at solving equations that take several steps to isolate the unknown variable. And such equations are referred to as multi-step equations. In this section, we'll simply be combining the steps we already know how to do. Our goal is to end up with all of the constants on one side of the equation and all of the variables on the other side. And we're going to do this by combining like terms. Now don't forget, like terms have the same combinations of variables in them. All right, let's look at an example. It says solve 3x plus 4 divided by 3 minus 5x equals 6. So this problem does involve a fraction. So before we can combine the variable terms, we need to deal with that fraction. So let's put all the terms on the left over a common denominator of 3. So the first thing we do is we write it out and we combine the fractions after we've put everything over our common denominator of 3. So now we have 3x plus 4 over 3 minus 15x, because when we multiply 5 by 3, we get 15, over 3 equals 6. Next, we're going to combine the fractions. So now we have 3x plus 4 minus 15x over 3 equals 6. Next step would be to combine like terms. So now we have the 15x and the 3x, so that gives us 12x. So we have 4 minus 12x over 3 equals 6. Next step would be to multiply both sides by 3, which gives us 4 minus 12x equals 18. Inverse operation, we're going to subtract the 4 from both sides, and we get negative 12x equals 14. We're going to divide both sides by that negative 12, and we get negative 14 over 12. So the solution for that, once we simplify it, gives us the improper fraction, negative 7 over 6. Not too hard. So let's also talk about solving multi-step equations using the distributive property. So you've seen in some of the examples that we can choose to divide out a constant or we can distribute it. Now the choice oftentimes is going to come down to whether or not we're going to get a fraction as a result. So we're trying to simplify the expression. If we can divide out large numbers without getting a fraction, then we're going to avoid large coefficients. So most of the time, however, we will have to distribute and then collect like terms. So let's look at this one. Solve 17 times 3x plus 4 equals 7. Okay, this equation has the x buried, I'll highlight it for you there, buried in the parentheses. So in order to extract it, we can proceed in one of two ways. We can either distribute the 17 by multiplying it, or divide both sides by 17 to remove it from the left. Now, if we divide by 17, however, we're going to end up with a fraction, and we don't want to do that. We want to try to avoid fractions if possible. So we've got 17 times 3x plus 4 equals 7. First thing would be to distribute that 17, which gives us 51x plus 68 equals 7. We're going to subtract 68 from both sides, and we get 51x equals negative 61. Then we just divide by 51, which gives us a solution of x equals negative 61 over 51. Another example. Solve. This one's a little longer, but just use the same steps. Don't let it intimidate you. 4 times 3x minus 4 minus 7 times 2x plus 3 equals 3. So this time we need to collect like terms, but they're hidden inside those brackets. So what we're going to do is we're going to start by expanding the brackets, and it's actually not that hard. So the first thing is to expand the brackets, then it looks like this. 12x minus 16 minus 14x minus 21 equals 3. So all we've done there is we've distributed. And then collect like terms, the 12x and the negative 14x. which gives us, there they are together in those parentheses, x minus 14x plus negative 16 minus 21 equals 3. So then we're going to evaluate each set of like terms, basically do the operations that are within the parentheses. So 12x minus 14x will give us negative 2x. Negative 16 minus 21 gives us negative 37 equals 3. We're going to add 37 to both sides. We get negative 2x equals 40. And the next thing we're going to do is just divide both sides by negative 2, and our solution is x equals negative 20. Another example here. Solve the following equation for x. 0.1 times 3.2 plus 2x plus 1/2 times 3 minus x over 5 equals 0. Long one. Again, don't get intimidated. Just use the same steps. All right, this function contains both fractions and decimals. So we should convert all the terms to one or the other. I personally like working with decimals more, but do whatever's easier for you. It's often easier to convert decimals to fractions, but the fractions in this equations are easily moved to decimal form. We know 1/2 is going to be 0.5. So, and remember that decimals don't require a common denominator, so that's kind of nice. So I'm going to do it rewriting it in decimal form. So I have 0.1 times 3.2 plus 2x plus 0.5 times 3 minus 0.2x equals 0. Then we just multiply out the decimals. We get 0.32 plus 0.2x plus 1.5 minus 0.1x equals 0. Collect like terms, all our x's together and all our numbers without variables together. We get 0.2x minus 0.1x plus 0.32 plus 1.5 equals 0. Next step, evaluate each collection or solve. We get 0.1x plus 1.82 equals 0. Subtract 1.82 from both sides. 0.1x equals negative 1.82. Next step would be to divide by 0, negative 0.1. And we get the solution of x equals 18.2. So not too bad, just more steps. All right, let's talk about solving real-world problems using multi-step equations. Now, they require you to translate a problem in words into an equation. So first, what you want to do is look and see what is the equation asking you. What's the unknown that you have to solve for? And that is going to determine the quantity that you're going to use for the variable. So the text explains what's happening. What you want to do is you want to break it down into small, manageable chunks and follow what's going on with your variable all the way through the problem. Here's an example. A factory manager is packing engine components into wooden crates to be shipped on a small truck. The truck is designed to hold 16 crates and will safely carry a 1,200 pounds of cargo. Each crate weighs 12 pounds empty. Remember, empty. How much weight should the manager instruct the workers to put in each crate in order to get the shipment weight as close as possible to 1,200 pounds? And I've rewritten the problem there for you if you want to pause it and refer back to it. So the unknown quantity, that is going to be the weight to put in each box, and that's going to be x. That's going to be our variable. Each crate, when full, will weigh x plus 12. 16 crates must weigh that. So then we have 16 times x plus 12, and this must equal 16 pounds. 16 times x plus 12 equals 1,200. We want to isolate the x first and divide both sides by 16. Gives us x plus 12 equals 75. The next step would be to subtract 12 from both sides, and we get x equals 63. Not so bad. So the manager should tell the workers to put 63 pounds of components in each crate. Just break up those problems into smaller pieces and you'll be fine. All right, let's talk about Ohm's law. The electrical current I, amps, passing through an electric component varies directly with the applied voltage, V volts, according to this relationship. V equals I times R, where R is the resistance measured in ohms. It's that little symbol right there. Here's an example. A scientist is trying to deduce the resistance of an unknown component. He labels the resistance of the unknown component X ohms. The resistance of a circuit containing a number of these components is 5X plus 20 times ohms. If, not times ohms. If 120 volt, let's highlight that, 120 volt potential difference across the circuit produces a current of 2.5 amps, calculate the resistance of the unknown component. So don't let the fancy new words intimidate you. Watch what we're going to do. We're simply going to substitute the numbers that are in the problems into the formula. So V equals 120, I equals 2.5, and R equals 5X plus 20 into V equals I times R. So we have 120 equals 2.5 times 5X plus 20. Next, we will distribute the 2.5. 120 equals 12.5X plus 50. Simply subtract 50 from both sides. Then divide both sides by 12.5. After we get the 70 equals 12.5X, then we divide both sides by 12.5X. And we get 5.6 ohms equals X. So the unknown components have a resistance of 5.6 ohms. Let's quickly talk about distance, speed, and time. So the speed of a body is the distance it travels per unit of time. We can determine how far an object moves in a certain amount of time by multiplying the speed by the time. So here's our equation. Distance equals speed times time. Pretty simple. Here's an example. Shanice's car is traveling 10 miles per hour slower than twice the speed of Brandon's car. She covers 93 miles in 1 hour and 30 minutes. How fast is Brandon driving? So here we have two unknowns, important to note, Shanice's speed and Brandon's speed. We do know that Shanice's speed is 10 less than twice Brandon's speed. Since the question's asking for Brandon's speed, it's his speed in miles per hour. That's going to be our X. That's going to be our variable. And I rewrote the problem up there for you again to look at. Okay, so substituting into the distance time equation is going to yield 93 equals 2x minus 10 times 1.5. Then we divide both sides by 1.5. We get 62 equals 2x minus 10. Add 10 to both sides. We have then 72 equals 2x. I'm going to divide both sides by 2, and we get 36x. So Brandon is actually driving at 36 miles per hour. Let's also quickly talk about the speed of sound. So the speed of sound in dry air is given by the following equation. V equals 331 plus 0.6 T, where T is the temperature in Celsius, and V is the speed of sound in meters per second. Well, let's look at this example. Tashi hits a drain pipe with a hammer, and 250 meters away, Min hears the sound and hits his own drain pipe. Unfortunately, there is a 1 second delay between him hearing the sound and hitting his own pipe. Tashi accurately measures the time from her hitting the pipe and hearing Min's pipe at 2.46 seconds. What's the temperature of the air? So again, don't let these fancy new words intimidate you. Just think of them as a formula that you just need to plug the numbers in for. So it is a complex problem, though, and we really need to carefully translate it into an equation. So the distance traveled equals 331 plus 0.6 t times time. Time equals 2.46 minus 1. Don't forget, the problem tells us that 1 second of sound, for 1 second the sound is not traveling. Sorry about that. And then distance equals 2 times 250. So our equation is going to come out like this. 2 times 250 equals 331 plus 0.6 t times 2.46 minus 1. Then we simplify our terms, and we get 500 equals 1.46 times 331 plus 0.6 t. And we have the 500 over the 1.46, so we're going to divide both sides by 1.46. Next, we have 342.47 minus 331 equals 331 plus 0.6 t minus 331, where we subtract 331 from both sides, gives us 11.47 over 6 11.47 equals 0.6t. We want to do the inverse operation there, divide both sides by 0.6, and we get 19.1 T. So the temperature is going to be 19.1 degrees Celsius. It's a longer problem, but if you do it slowly and step by step, you should be able to work through it with no problem. Let's quickly summarize what we've learned in this lesson. So if you're dividing a number outside of parentheses, it's good if dividing a number outside of parentheses will produce fractions, it's often better to use the distributive property. And I'll highlight that. So for example, 3 times x plus 2 equals 3x plus 6 to expand the terms and then combine like terms for the equation. All right, everyone, that just about does it for this lesson. Thanks for joining us, and we'll see you next time. Bye-bye. So